Hi everyone, welcome back to chemistry. In this video, we're going to talk about something called significant figures, also known as Sig Figs. So anytime we take a measurement, there's always some degree of uncertainty in that measurement. We're human, we make mistakes, we can't be perfect. And even if you're using some kind of automated measuring device, humans still created that device, right? So there's always going to be some degree of uncertainty in our measurements. And in science, we want to make sure that we're reporting our findings or our data ethically. And part of doing that is making sure that you are communicating that degree of uncertainty in that data to your audience. So the way that we do that is we use these things called significant figures or Sig Figs. So the idea is, say we're looking at this ruler here, and these are in inches, and I'm measuring this kind of block of metal here. And I'm noticing that this is where that kind of block of metal gets to on our ruler. Okay, and I have some tick marks here, so I know this is 1.1, this is 1.2, this is 1.3, and this is 1.4. So it looks like the block gets in between 1.3 and 1.4. It definitely gets past 1.3, right? But it definitely does not get to our other tick mark, 1.4. So I don't have a tick mark here to measure exactly where we get to. I know it's between 1.3 and 1.4. So I'm going to say, whoops. So I'm going to say I get at least to 1.3, but the next decimal place is uncertain because I'm estimating that last digit there. That's my estimated digit. Okay, so I would say this is probably about, 1.3, maybe 536, 1.36 maybe. And each of us are going to kind of think of a different measurement. We're going to estimate that just a tad differently. But we know these two digits for certain because we know it gets to those digits. I have a tick mark there. Next, let's talk about some of the rules for Sig Figs, because Sig Figs are sort of a bookkeeping method, and scientists kind of made it up, right? So it's just for our purposes to kind of track how certain we are in our measurements. So we have some rules. The first rule is that all non-zero digits are significant. Okay, and what does that mean? So all of these digits in this reported measurement here, 1,357 millimeters, those are all Sig Figs. Okay, they're all Sig Figs. So we would say here, because all of these 4 digits are significant, this number has 4 Sig Figs. And you'll sometimes see that abbreviated as SF. Or as Sig Figs like this. 4 Sig Figs. All right, the next rule is that sandwiched or embedded zeros, those between significant digits, are significant. Okay, so what do I mean by that? Well, in the first rule, we said all non-zero digits are significant. Well, so this is a significant digit, and this is significant. And now in our second rule, it says that these sandwiched zeros, sandwiched in between 2 non-zero digits, they're also significant. So the neighbors kind of make that 0 in between significant. So how many does this number have? How many Sig Figs does that have? Yeah, it has 3 Sig Figs. Okay. All right, the third rule is that leading zeros, or zeros at the beginning of a decimal number that's less than 1, so any number that's less than 1 that has all these zeros in front of it, right? Those leading zeros are never significant. Those zeros are not significant. So I'm highlighting all those leading zeros right now. Those zeros are not significant. So if we're looking at this number here, how many Sig Figs do we think it has? And there's an answer there for you, but yeah, there's 3 Sig Figs here, right? Because these are all non-zero digits. So we said in rule number 1, those are all significant. Okay, so those are significant. And we said leading zeros, these here, are not significant. Okay, so this has 3 Sig Figs. All right, now trailing zeros, or zeros that come at the end of a number, like these here that I'm highlighting, those are only significant only significant if the number has a decimal point. Only significant if the number has a decimal point. So for instance, in this number here, are those trailing zeros, are they significant? No, there's no decimal point reported for that measurement. And decimal points are really important. In chemistry, anytime you see a decimal point, there's a reason that decimal point is there, and it indicates something about the certainty of that measurement. All right, so we don't see a decimal point here. Okay, so these two zeros are not significant. So how many total sig figs are in this number? Yeah, 2 sig figs. 2 sig figs total in that number. Actually, let me put that down here. This one and this one. All right, and in the next one, how many sig figs do we have in this number? Remember, those trailing zeros are now significant because there's a decimal point in that number. So take a guess. Yeah, there are actually 6 sig figs here. Why are there 6? Well, remember, our 1 and 5, those are both non-zero digits, so they are significant. And then we have a decimal place. So any trailing zeros, and there's 4 of them, are significant. Okay? Sometimes students get confused and they want to just say, okay, there's 2, or maybe there's 2 here, right? No, all of these zeros get counted. It doesn't matter where the decimal place is. Okay, those trailing zeros, any zeros that come after your non-zero digits, are significant. And you might be like, well, Kayla, up here you said that these zeros were not significant, but there is a decimal place. Why are these not significant? How is this different? Yeah, these are leading zeros. These are leading zeros, right? So they come before the non-zero digits here. So those are not significant, but our trailing zeros are. Okay, I know, kind of weird. You'll get the hang of it. Okay, so let's practice. Okay, so, and I'm going to say this little graphic up here is really helpful, but I do want to, we used a different vocabulary word for buried zeros. We said sandwiched zeros. So I'm going to put that there. All right, so how many sig figs are in the following numbers? Pause the video, try it out. You can be wrong, right? This is the perfect time to be wrong instead of on a test or a quiz. All right, so 4097, how many sig figs? Yeah, that has 4 sig figs. So let's look at this. Any non-zero digits are significant. So this is significant, and this is significant. Significant. How come there are not just 3 sig figs then? Yeah, we've got that sandwich zero, right? Sandwich zeros are significant. It's sandwiched between that 4 and that 9. Okay, so that is significant because it's sandwiched. So that gives us 4 sig figs total. What about on the next one? Let's take a look at this. So we've got 2, 8, and 3. Those are all non-zero digits, so they are significant. So I've got at least 3 here. What about these zeros in the front? Are those significant? No, those are leading zeros. Leading zeros are not significant. So no, no, and no, not significant. What about this middle zero right here? Yeah, that one's significant. Sandwiched, right? So again, 4 sig figs. All right, and then what about 300 here? How many sig figs? So it's a little weird. There's only 1. Why is there only 1 sig fig here? Yeah, we don't have a decimal point. We don't have a decimal point. So let's take a look at this. So 300, just as it is right now, we've got our 3 here is significant. But the question is, are these zeros significant? And they are not. So if we had a decimal point here, would those zeros be significant? Yeah, absolutely. And then you would have 3 sig figs. But because there's no decimal point there, we cannot count those trailing zeros. Okay, because there's no decimal point, we can't count those trailing zeros, and there's only 1 sig fig in that number. Okay, so when you make a measurement in lab, if you measure something at 300 centimeters and you know it gets exactly to 300 centimeters, you're going to want to put a decimal point in there because you want to tell your audience, no, I am certain of those 3 digits there, okay? If you just put 300, we're going to think that your measurement isn't as certain as it is. And we'll practice this, okay? All right, so when we round a number, we first want to decide how many sig figs that number should have. So say you know in your measurement that you only have 3 sig figs available, that is how certain your measurement is. But your calculator, when you're doing a bunch of calculations, spits out this big long number. And you need to round that long number so that it is expressed with only 3 sig figs. How are we going to do that? All right, so just like you round any number, if we want 3 sig figs, we're going to want to look at this number here and say, okay, is my next door neighbor 5 or greater? If your next door neighbor is 5 or greater, then you're going to round this digit up. Okay, in this case, yes, my next door neighbor is 5. That's 5 or greater, right? So we are going to round this number, that digit, to 2. So we're going to have 202. And that would be your final, that would be your final answer, 202. Okay? And that is 3 sig figs. Now, notice that this number is close to this number. If you ended up with a number that was really far away from your original number, then you know you might have done something wrong when you rounded. We don't want to change drastically our answer, right? We just want to round it to the correct number of significant figures. All right, so we got a couple more rules for you. So when you are adding or subtracting your measurements, so say you're in lab, you have a bunch of data points, and you need to add those data points up. We still need to take sig figs into account. All right, so the rule here is you want to stack all of your numbers with their decimal place lined up. Okay, so see their decimals lined up here, or their decimal points, sorry, lined up. And then when you do that addition, you want to round to the lowest decimal place. So what is that in this addition here? Yeah, it's the 10th place. Okay, that is the lowest decimal place. And let's think about this for a second. Which one of these, the red, the blue, or the green, is the least accurate? Yeah, it's going to be the blue one. And why is that? So think about the more accurate number is the one where you have more and more decimal places that you are certain of. So in this red one, we are certain to this decimal place. And this highlighted one is our estimated digit. In the next one, in our blue example, we are certain to this decimal place. And the last one in yellow is our uncertain digit. And then all the way back here again, we are certain to this digit, and this last one is our estimated digit. So these two, the red and the green, are both more accurate, more certain than the middle number, okay, than the blue. All right, so again, what we want to do is we want to line up all our decimal places and then round to the fewest decimal place. So when we get to our final answer here, our calculator is going to spit this out, and we want to round to the 10th place. So we're going to round to this number right here, or that place right there. So we got to look at our next door neighbor and say, okay, is our next door neighbor 5 or higher? In this case, yes, it is 5 or higher, right? It's 8. So we're going to round this number to 1. So we would round this to 1459.1. That would be our final answer expressed with the correct sig figs. All right, so one more rule. For multiplication and division, you want to count the number of sig figs in each of your numbers or your measured values, and then you want to round your final answer to the lowest number of sig figs. Okay, so up here, for adding and subtracting, we were rounding our answer to the fewest decimal places, to the lowest decimal place, okay? And over here, we're going to round our final answer to the lowest number of sig figs. And I'm going to say lowest number of sig figs. Okay? That's what lowest count means. Lowest number of sig figs. All right, so what they did here is we counted, right? This number has 4 sig figs. This number has 5 sig figs. So how many sig figs should your final answer have? Yeah, 4. So we only want to round this, your calculator is going to spit out this giant number, and you're like, no, that's not how certain I am. I want to be an ethical scientist, and I want to show how certain I am in my measurement. So I need to round this to 4 sig figs, and that's going to look like that. So you want to look at this, you want to round to that spot. So you need to look at your next door neighbor and say, okay, is that 5 or greater? If so, you're going to round up. If not, you're going to leave it the same. In this case, 1 is not 5 or greater, so you're just going to leave this as 4094, and that's your final answer.